Namaskar. So in this video, we are going to discuss a very beautiful question that has been asked in December 2015. Yes, the question was related to the concept of meromorphic function. And in the previous lectures, we have discussed that whenever you are asked for meromorphic function, then certainly in that particular domain, there should not be any essential singularity. Okay, so first of all, you will find the singularities, all possible singularities you need to write. And for that, what shall you do? Certainly e to the power z minus 1 is equals to 0. So from here you shall write e to the power z is equals to 1. And how can you write this 1 in terms of exponential? Certainly e to the power 2k pi iota. Alright, because this will give you what? Cos 2k pi plus iota sine 2k pi. Right? And sine k pi will give you 0, cos 2k pi will give you 1 for any integer k, you can say. Alright, so now you can see what? Here your singularities are what? Z is equals to 2k pi iota. Yes, this is the thing right there. So you can see what is your domain. Your domain is C. So first of all, we have to check the nature of these singularities, right? So now, would you like to say that it is going to be removable? The answer is no. Why? Because limit z tends to a, 1 by e to the power z minus a 1 is not going to exist, does not exist. What is the reason behind it? Because if you will take k is equals to 0, then e to the power 0 will become 1 minus 1. So 1 by 0. Okay, does not exist finitely. Even if you will take any other value, I mean to say k is equals to 1, then 2 pi I. However, e to the power z will give you 1 and 1 minus 1 0. So in all these cases, you are able to see that this does not exist finitely. Therefore, it is not a removable singularity. So not removable singularity. So certainly it will be what? Pole. And how this pole can be seen right here? Certainly for k is equals to 0, you are able to see your pole over here. For k is equals to 1, it will become 2 pi. Okay, this I represents what? All the poles will be on the imaginary axis. For k is equals to 2, it will become 4 pi. For k is equals to 3, it will become 6 pi. And this story will be going on up till infinity. Okay, yes. So you can say what? All the singularities are what? Poles only. Okay, all the singularities are what? Poles. And certainly you can find its residue, and you will get that residue is equals to 1. How would you like to say it? Certainly limit z tends to a, z minus a, f of z. If you will find, then certainly you can check it. But intuitively, you can also see that the multiplicity of each pole, for example, k is equals to 0, it's 0. For k is equals to 1, it's 2 pi. For k is equals to 2, it's 4 pi. For k is equals to 3, it's 6 pi, and so on. So you can see what? Here is one pole, another is over here, another is over here, another is over here. And by doing so, you can see there are infinitely many poles. So certainly when you will reach at infinity, then in the neighborhood of infinity, you will be able to see infinitely many poles. So infinity will be the limit point of all these poles, and in C infinity, your f is not meromorphic, because in C infinity, at infinity, you are going to get an essential singularity. But our domain is what? C. And in C, we don't have any essential singularities. The only possible singularities are nothing but the poles Therefore, you will not hesitate to say that F is meromorphic in C because C is your domain. The only singularities of F are poles. Certainly we are able to see. Yes, 0, 2 pi, 4 pi, 6 pi and so on. F has infinitely many poles on the imaginary axis. Yes, on the imaginary axis, on the y-axis you can see 0, 2 pi, 4 pi, 6 pi, 8 pi. These are the poles which lies on the imaginary axis. So certainly we shall say yes. And the multiplicity of each pole is what? Only 1. Okay. So 2 pi repeats only one time, 4 pi repeats only one time. Even if you will find its residue, then certainly you are going to get 1. So certainly you can say each pole is simple as well. So simply you can say all the options A, B, C, D, all these are correct, isn't it? So on which topic do you want some interesting questions? Please write in the comment section, give the feedback, and certainly if you have any doubt in this question, then comment section is there for your suggestions. So we'll meet in the next video. Till then, take care, bye bye. But yes, don't forget to check the playlist. Many interesting things are there for you. Thank you.